This video will cover using Advisor Analyst X software to build and create models. This video will contain 3 parts. The first, we will go through the software and explain how to build the model. The second will be explaining the model results page and how to interpret the model. And the third final part will go through some advanced options within the model building. So first, you want to have Analyst X, not just the regular analyst license. To access your modeling, you want to go over to View and click on Predictive Model. This will open the Predictive Modeling pane on the right-hand side, where you'll have access to options of creating and looking at various options for the creation of the model. So just a little background on what this project that I currently have opened contains. I have a simple project that has alumni, and I have some various factors that I brought in using the link expressions or various calculations. You can look at our other tutorials to see how to do those exactly. But for now, we've brought in all the factors that we want, and we're ready to do some modeling. So I have some simple factors such as the number of alumni committees participated in, some giving-related factors, other factors such as the number of reunions, sports, and student activities as well, and volunteer committees. So some more related to attachment and engagement rather than just straight-up giving, but we also have the total lifetime giving as well. And on the second page, I just have just a chart of the ratings and the total lifetime giving bins. So today, let's just start off with building a model. So to build a model, we click New Model, and we can choose what to call our model. So we can call this an attachment model. And we want to choose which data table to work off of, and we're going to be going off of the alumni. And we're going to be wanting to know a target field. So now we can either choose for a straight-up logistic regression model, we can choose a 0 or 1 field. Or we can, if we want to do a linear regression model, we can also just choose a field here. One of the fields in our table as well, which don't have to be a string, but it can be just a straight regular number. Now, we're going to want to, for the purpose of this example, I'm going to be working off of a field that I already created, which is target, which I simply put if the total lifetime giving bin is over 100,000, then 1 else 0, which is a way to make it into a logistic regression from just the simple strings here. However, another way I could have done this is, let me exit out of this here. If I make a selection on my target, and then we can do new field from selected. And if I click that, it will store the table selection under the field current selection. So you can see now here there's a current selection field. Now this is the same thing. It will give a 1 for wherever I selected and a 0 for everyone else. So it's another way to go about doing things if you don't want to manually make the target. So you can just put in make a selection and then build a model off of that selection. So let's do that for now, and I'm going to uncheck most of these. Let's build a simple model, and I'm just going to maybe focus on attachment for now. And let's do alumni committees, maybe number of unions, sports, student activities, and volunteer committees. Now obviously I don't want to model on ID number, I can't do it on name. And rating and target, rating and the TLG bins, we're kind of, those two are pretty highly correlated already, and we're using the TLG as a basis for our selection for our target. And so it's not really relevant to, it's going to tell us what we already know, that TLG is an influence on the factor, but that's kind of why we chose it. So I'm just going to stick to these 5 categories for now, and let's call this attachment model. And once we're satisfied with our explanatory fields, we can then click Train Model. And over here on the right, it will show the accesses, just a way of progress. And once it's done, it will output 2 pages. You'll notice attachment model 1 and attachment model 2 that are now created with various model statistics and information as well. So I just want to go through, before I go into just the interpretation of this model and using the model for other, attachment scores and things like that, just want to go through just some of the options here. Here, I edit the model. Let's say I wasn't happy with some of my selections here, or I want to redo, maybe, add a couple more explanatory fields, take out some explanatory fields, make adjustments. I can just, easily change that and then click Train Model to retrain the model and edit it. Delete the model and View will show these 2 pages again. Typically, the model will be saved within your project, but these 2 pages won't necessarily be added always to the project. So if you have a large project and you don't want to see these 2 model pages all the time, it's not there. And instead, if you want to look at it more closely again, then you can click View, and these 2 pages will open up. This models drop-down menu, if you have multiple models, you can look at more than one model and just select which ones you want to be working off of and view at the same time. For now, we only have one model, so that's one I'm showing up here, attachment model. This pane here just gives you information regarding the model and its creation. Target field just tells us which field we were working off of, and we call this the current selection. Accesses just tells you how many times the data was accessed, and it's a little bit more on the back end of just how the model was going. Concordance will be also known as, for R-squared, there will be an R-squared here for the linear regression, but for the logistic, we have percent concordance, which is, a quality metric, essentially. It just tells you how good the model is. You want that, 80 to 95 is pretty good, but anything above that, it's a bit too high concordance, and you might be overfitting the model. But, it will generally be colored appropriately. Lower numbers, it's a weaker model. But, here, 81%, is pretty good. Time here just shows you how long it took to create the model. It's pretty quick. Predicted field, what will happen is the model will output some scores, and it will put that scores into a field, and this is what it's called. It's score attachment model. And we did a classification type. And the training set, we looked at 24,000 rows in our data. And right now, I'm only looking at alumni, so you might want to adjust your training set appropriately. Now, I'll go into the discussion of the model outputs. So it'll be this page as well as this first page. I'm going to start off with this first page here, which just gives you an overview of the results of the model. So starting from the left, we have our percent concordance, just a nice visualization of this number here. So it's just 81%. You have 0.81 roughly here. The second box contains a list of the fields, explanatory fields, the categories within that field. So if this was a categorical field with something like the entity record type or the state, if it was like a yes or no kind of field rather than the numbers that I have in current one, then you'll see which category was impactful. We also have the coefficients. So this gives you the raw coefficients that the software uses to create the scores. And generally, the higher coefficients, right, are positive impact. Negative coefficients are negative impact on the model. So here, just looking at this model, we can see that the number of alumni committees has a pretty strong impact. The number of volunteer committees in the last 10 years also has a pretty good impact. Reunions a little bit less, and then student activities seems to be a negative, which is unusual and kind of cause for some discussion there, see what's going on. And sports also seems to be not, doesn't seem to be relevant to the model. And on the right, we have transform, which it's an optional adjustment that the modeling software makes, just in case in things where they don't behave strictly linearly, and instead are perhaps, there's some diminishing returns after a certain point. The difference between maybe someone attending, 5 reunions and 6 reunions might be a lot less than someone who attended, 12 and 13. So, at a certain point, you might get some diminishing returns. And the transform here, if there is something here, looks like ours is pretty linear for this case, the transform will take care of any kind of deviations from linear behavior as well. So moving on to the field impact of the model. This, as you can see, is a little different than just pure coefficients, primarily due to the fact that the coefficients are mostly numerical, and we want to focus what doesn't take into account as much the average value of a field. For example, people might tend to have gone to more reunions than in more volunteer committees. So even though the coefficient is larger for the volunteer committees, people haven't really gone to as much. So the overall impact is perhaps less than the number of reunions. People might come out to more reunions than they are on volunteer committees, which makes sense. So even though the coefficient here on the left-hand side is smaller, the overall impact of the field is a much larger impact. So this field impact tells you just really a combination of both the coefficient and the average. So ultimately, if you want to look at how impactful are my reunions, we can see here that they're pretty impactful, although that might not be immediately apparent here in the coefficients page. However, these coefficients are still useful in that they give you the exact numbers that the model uses to make the scores and the equation used there. Here we have just a target, how many were in our current selection. And so these were the people that, if you notice, here on the 100 and K above, so those are the same people. And the 0 are all these less than 100K, so lifetime giving. Finally, the two score charts here. The first one is just a histogram of the score, and it varies from 0 to 1 in cases of the logistic, and typically just range is typically highly skewed left, and the spin score is a simple 5 even split of the score. So from 0 to 0.2 to 0.4, 6, 8, and then 1. So this spin score also just gives you an idea of the distribution, although that's also seen here in this histogram here. The second page here just gives you a heat map visualization of the coefficients that we saw here. So we see just, this is one bar chart that just gives you relative impact as well. And this first heat map also just shows that similar relationship as well, with red being the most negative and green being the most positive. The same information, nothing new displayed here, but just another visualization to help see things. This is quite helpful for when you're seeing categorical data in which the field, number of volunteer committees, such as this one, will be subdivided further into each individual field. So you will see how each individual category within the field has on the overall behavior. Finally, I just want to go through a little more on the advanced options here on the right-hand side. We have a couple of additional options here to kind of tweak and adjust the model behavior as you see fit. The first one here is p-value, which is just a measure, for those of you who aren't as familiar with statistics, it's just a measure of how much coincidence or how rigorous we want our model to be. So if we want something that might have a smaller relationship to be allowed, then we'll allow a little bit more fields to be relevant. Whereas if you want a smaller value, and we can go all the way to 0.0001, you can be very strict on what kind of fields you want. So you only want those fields that really have a statistically significant impact on the model, whereas this one is the higher numbers are a little bit more lax, allowing for to see certain things that really some connections that might not otherwise be seen. Typically, it's set at 0.01, but most of these values are fine for use. We can also adjust the training subset. Currently, we used 24,000 out of the 24,000 rows, whereas we can adjust this if you want to model off of a smaller subset of the behavior. We can just adjust the slider to only look at 50%, and then we can adjust, do we want a random, do we want the first, the last, or stride as well. So this helps just, typically it's set at random and at 100%, so you look at all the data that you have, but if you want to adjust it, it's here. Run equations with the project just tells us whether or not to run the equations where we'll score and score everyone as the data gets updated. The model is not rerun at each opening of the project, so these coefficients, once they've been set, can be used continuously with the update of your data. So let's say someone attended a new alumni attended a new reunion or was a part of a new alumni committee, and that data got refreshed and added in last night, then their score will reflect that once you open it up. So you can adjust that, tolerate that behavior if you don't want to rescore the model each time. And name bins allows you to rename these bins instead of just a 0, 1, 2, 3, 4. You can just rename them by clicking that and renaming these bins here. Finally, in this bottom part here, we can exclude rows from prediction. For example, I currently only am looking at the alumni already, so I'm looking at 24,000 alumni. But for example, if I want to have a model on in a larger project that doesn't have only alumni, we might want to only focus on behavior of alumni due to the fact that they behave fundamentally differently than friends or other types of entities. And so because of that, we might want to have some rows excluded. So for example, here if you want to do not predict and do not exclude and exclude, let's say I decided, for example, here to exclude the low rated. So the bulk of this lower, and we can see some things here who are low rated, but they have still they gave at target level. But for example, if I want to exclude these, I can do an exclusion here. And when I train the model, it will show that I excluded these anyone with a rating of 0, 9. And this is helpful for just if you're running a model and you want to just double check what your population that you ran the model against was. It can just be helpful for just saying, oh yeah, I remembered I did not include alumni in this. This was a friends-focused model. This was a new donor, a young donor focused model, and it can help just keep track of things there. Finally, we can select do not predict rows from model where, clicking this, and we can choose to withhold the score for a certain group of people. So let's say I don't want to score, I'm looking at alumni, but I don't want to score young alumni. Then I can specify that here. If I have a field that says it's a young alumni, let's say I have a field that's called that, and it equals yes. And so what this will do is it will not score whatever kind of categories that I've listed here. So if I also want to say, whether young alumni or class year is equal to 1980. So this selection box here uses the same syntax as our expression builder up here, and can certainly be just used to, I don't have a young alumni field, but it can be used to specify which rows to not predict from. So it will not include them for scoring wise, even if you want to build a model up. If we want to take a look at how these coefficients are used, in order to create the score, we can go into the project workshop, open up the alumni entity, the whatever field that table that you're working off of, go down to score attachment model, and let's click the source here. This is just another expression within our expression builder, and here you can see the coefficients in front of each of these fields that are relevant. So there's 0.210 for alumni committees. There's also here 0.211 here, just a slight rounding. Reunions, volunteer committees, and student activities. So this is the actual equation used to create the attachment model. And it's a logistic, so this log it does the 1/e to the x kind of expression here in order to give you the score that's in this histogram here.